Vamos a empezar con la última presentación de la tarde, porque después de esta presentación viene el Kahoot que vamos a explicar. Y en esta presentación Janusz nos va a hablar de medidas de Internet en inglés. Y además nos va a ofrecer la posibilidad de acceder a ellas, o sea que vale la pena escucharle. Y por visto.
Thank you. Thank you. Do you guys hear me well? Okay, thank you. I'm Janusz. I represent Speedchecker, and this presentation is about internet measurement. Just a quick show of hands. Do you guys know RIPE Atlas? And have you guys done measurements on RIPE Atlas? Okay, great, fantastic. Okay, so this presentation is about also about RIPE Atlas, and we run a similar measurement network like RIPE, and we want to showcase what we do, and we also want to offer to anyone in here free access. So if you guys want to run measurements, this presentation is about alternative options. So quick agenda for today. Just introduction of a very quick introduction of Speedchecker, then what sort of measurement platforms are out there, the coverage, it's very important for measurement networks, very quick overview of how you can actually run measurements on Atlas as well as on our platform, and we're going to show you some sample measurements and comparison between the platforms. So very quickly, Speedchecker is a small company founded in the UK with original mission of helping users to test internet speed. And after a few years and many measurements, we realized there's a demand from ISPs and different companies to offer tools to them so they can offer speed tests to their customers. And by operating this, we realized with many servers around the world, we realized we need a platform where you can measure performance from many different vantage points, and therefore we created the active measurement network, and this is the scope of the presentation to show you how it works. So what do we have here? This by no means is a comprehensive landscape of a measurement network. There are others, NLNOC, Planet Lab. This is merely to show you what we have, plus the context of RIPE Atlas, which is probably the most similar platform to ours. Our platform enables you to run measurements on hardware probes. So these are the router probes here. They are probably the most similar to Atlas. They are run on end-user routers around the world. We have currently about 4,000 probes. Then we have software probes, which are running on PC and Android. There you can see coverage on the software probes is, of course, much higher because it's very easy to deploy the probes. You don't have any hardware costs, which is actually also the case with our router probes. We often users, they enable us to test on their routers, so we actually don't have to pay for the probes as RIPE has. So our goal is really to grow the network, and with those free platforms, we are able to target different countries. Apart from coverage, what is also important is what sort of tests you can run on the network. So here you can see our router network. Router probes are actually quite limited, but they still do offer some interesting measurements. So you can run HTTP measurements on them, but you cannot, for example, at the moment run DNS, which RIPE enables. Our software probes, they have more options. We also have some application tests such as loading web pages and video streaming. And in the next slides, I'm going to talk a little bit more in detail. So how do we have, how is it possible the router probes are online? So we partnered with DD-WRT, which is the biggest open source routers, firmware, and so DD-WRT has over 500,000 downloads of its firmware every month, and part of the network basically consists of users who allow us to use their routers for testing. In this example, you can see if you install DD-WRT on a high-spec router, this is not supported on all the routers, but on the high-spec routers you have a speed testing feature there, which probably more useful is the Wi-Fi test in there, which actually is able to compare internet speed versus the Wi-Fi speed. So basically speed from your end device to your router, and this helps you for troubleshooting. So essentially, users who want to use the Wi-Fi speed test, they need to opt into our measurement network. At the moment, we have about 4,000 of those probes, and growing every day by about 50 probes. PC probes, so these are Windows computers of users who want to use our scheduled speed test. So essentially, they opt into to the testing network by downloading a Windows application. Android probes, these are users of our Android app. It's a popular Android app for measuring internet speed, and users need to agree to background testing on Wi-Fi. Here, the important point is we don't do any testing on mobile data yet. Of course, mobile data plan is sacred. It's scarce resource, so we don't do the testing. But we are planning to incentivize users, basically contribute part of their data plan, so we can offer it as well. So this is, let's say, comparison of the available options in terms of coverage. As you can see on the top side, routers and our routers and the right Atlas, they have a similarly looking geo distribution where the way to analyze this map is like a heat map. So the red parts, hot, is a lot of coverage. Blue, dark blue is no coverage. So you can see pretty much if you want to run measurements in Europe, you are fine with Atlas, you are fine with our routers. Pretty much any platform will have coverage in Europe. The same with Northern America. But if you want to run measurements, for example, in Latin America, then that's where, for example, Atlas and also our hardware routers are not that distributed there. But the software platform has more availability in Latin America. All the platforms have issues with Africa, and there are not that many probes in Central Africa, mostly South and Northern Africa. This is just a very quick overview on how you can actually run measurements on Atlas. For those of guys you already run the measurements. For those who haven't run, this is very easy and it's meant to encourage you to use the platform. So if you want to run on Atlas, you need credits. Essentially, every measurement consumes credits, and there are several ways how to get them. So you are a right member, layer member, or you are hosting a probe, you can get credits to use for your measurements. This is sort of the interface that you use to run measurements. So you first define the type of test, then you select the probe. They have a very nice interface to pick the probes you want, and then you just specify if you want to do one-off, so just a quick troubleshooting or research, or you want to continuous measurements with starting now until some point in the future. Once you start getting results, you have several options to analyze them. So they have a very nice latency one, which is for monitoring purposes where you see the probes on the chart. Then you have a map visualization, like here, where you can see the results in map format. And for our purposes, because we want to compare the results to ours, we need the raw data, we want to compare it, we want to filter it, so we use export. So Ripe Atlas offers JSON export. JSON might not be looking very friendly at first, but it's actually very easy to convert. So for example, with this online tool, you can copy paste it spits out the CSV and then it's in the database format, so it's very easy to analyze. I like to use Excel, of course. There's so many options how you can analyze the data. I like Excel. It's no programming language necessary. It's very easy to visualize stuff. So if you are not familiar with pivot charts, it's like a pivot tables. You prepare the data and then click on an icon, and it's basically you don't even have to change anything. It just does something like this. Here you need to basically put on typically you want to have different probes on the legend to analyze which probes may be behaving. Then you have on the x-axis you have time axis, and then you have the latency here. So in this case we are running a ping measurement. It's for about 1 hour. You can see between 3:20 until 4:30. About 30 probes, random probes from Spain, and testing, in this case, elpaís.com. It's hosted on Akamai. Quick ping times, very stable, which is able to show us which probes might not be as stable. So how to run measurements on our platform? You need an API key. As I mentioned, anybody who wants to run measurements, just at the end there will be instructions. If you want to get an API key, it's free to use. You can either use user interface, such as this maplatency.com for one-off measurements. If you want to do continuous measurements, then you need to use an API. So in this case, yes, we want to run 60 minutes, 60 samples in 1 minute interval from different probes in Spain. So essentially, we have a set of HTML files which are open source, where you basically, it just fires up API requests and then produces you data in format you want. So in this case, after 1 hour of running from those probe IDs with ping to elpaís.com, you get this sort of table, and you just copy paste it. In this case, Excel analysis is really easy. You just copy the CSV, open it, insert chart, and there you go. You have something like this. So this is unfiltered data, which has a lot of noise. And so to explain, so here, these are the router probes. You can see majority of the results are let's say, sub 15 milliseconds. Some probes, when they go to 0, that means the probe is not available. On the PC probes, there is a difference here. Of course, router probes connected on the LAN. PC probes, as well as the others, there's a wireless noise, which gives a lot of, let's say, complications for analysis. So the best actually is to exclude the probes which are behaving like this, which probably shows wireless noise. The same happens here on Android, as well, a lot of noise. On mobile, this is still not available to the public, but there's a different sort of problem there, where the mobile probes are not as available. So we are not probably going to offer a monitoring functionality from the data plans. This is going to be more for research. So if you want to check the availability, you want to check, you want to run some one-off tests from mobile rather than continuous testing from mobile. And finally, this is more of a comparison of the results. So you can see on the left-hand side, these are the unfiltered results which I shown earlier from the previous slides. Our results from Atlas, earlier results, and we're gonna zoom in on this part. Let's say sub 100 milliseconds. So in here, okay, we exclude those two, and you can see the noise here, but you can see the majority of the results are essentially between 10 to 30. The same here. If we exclude those two results, you can see the majority is here. This is really to show you that the results are comparable, even though it runs on a different hardware, and you are able to use them for your monitoring or research needs. So essentially, just to conclude the presentation, when you're deciding to run measurements, you need to know about what sort of coverage you need, what sort of tests you want to run, and then you have options. What, depending on the coverage, depending on the tests, you can decide between different platforms. So this is it. Before I leave to the questions, so if you guys want to use our platform, just head to this URL. Just click ESNOG, and we'll provide you the access so you can play with it. You can run tests if necessary. So thank you, and yeah, if there's any questions.
Thank you, Janusz. Are there any questions from him? Are you going to request access to this API?
I'm doing it.
Okay.
Well, I do have a question. Thank you, of course, for the presentation. I'm wondering, how do you handle the different hardware platforms that the DD-WRT might be running on? Is there any labeling of the data submitted to the system, or can that be filtered on? Is it not right now, but might be in the future?
So at the moment, the biggest problem we have is really that most of the routers actually don't have much memory, and
flash or RAM?
well, it needs the. I don't know what sort of memory we need, but it's more for the technical guys. But yeah, this is the constraint where we cannot put all the probe software on it. So that's why it runs on the high-end routers. If we're able to put it on all the routers, then of course we wouldn't have 3,000 routers. We would have maybe 100,000. So we are working on minimizing the code and still keeping the functionality in there. And we do have the list, okay, which when you're running measurements, which routers run on which router brands. But at the moment, this is not available outside. I haven't had this request, but yeah, if there's an interest, for sure we can disclose the router brands.
Okay, I guess that in principle you don't really need to do any filtering. What you see confirms what you expect.
Mm-hmm.
But if you see, anomalies, it would be nice to be able to, inspect where the measurements are coming from.
Mm-hmm.
Try to rule some out, perhaps.
Yeah, we do see anomalies. You can see it on the charts that some probes behave in different ways. But yeah, it can be due to the placement, right? It can be to a network, lot of things. So definitely, there's a lot of things we could analyze and change.
So far, the UI looks gorgeous. I really like it.
Any other question for him? No. Thanks again. Thanks for coming and for sharing. Y bueno, ya hemos llegado.